Hi, today is day 154 of my journey to Google, and I did the all ancestors of node in a directed acyclic graph. So this is a good question. I suggest you try it out if you have studied about topological sorts and tree sets and all. So it's a combination of all these. So basically you have to write all the ancestors and it should be in ascending order. So if you're writing for 3, it should be 0 and 1 instead of 1 and 0. The list should look like that. Here is the list. So for 4 you have 0 and 2, and for 7 you'll go like 0 and then 1 and then 2, then 3, like this. So as it's a topological sort, you basically first keep an in count. So here you see, like I think over engineered it. So first I keep an in count and I create an adjacent list matrix, like it should be matrix. The reason I created matrix is like when you are going for the child, you want them in sorted order, and since the constraint was 1000 nodes, I think it can be tolerable. So I did that, and so when you're traversing, you just check if it's a child of that or not. So at the end when we are traversing, I see okay if it's a child of it or not. If it's not, I'll just continue, else I'll go with the process. So we just keep adding our response in a linked hash set. Why linked hash set? Because we want to preserve the in count. So because we'll be inserting in sorted order, and once we take it out, it should be in sorted order, and also we want to avoid duplicates. So for that, linked hash set was good. And then for response, I have created a tree set. So why tree set? Because I want to keep in sorted order. Here sorted order might not be the case, because as you can see, for 7 what we have is 3 and 2. So there can be a case like you like 3 doesn't have many children. Let's say that for now it is 2, it is 3. So we'll see, okay, 3 already ended, but there was 2 also on the way. So for that we want to preserve the order, because 2 will be free first, so in count will become 0 for 2 and it will be free. So if we update its children now, then it will be ambiguous, because there will be 2 later on here. So that's why we use a tree set. And after using the tree set, we are just traversing and then adding, and then for returning the answer I just create a new array list, because they want the answer in array list, and I return it. And that's the update for today. Thank you.